Hi everyone, welcome back to this video on Bitcoin. Transactions, blocks, mining and the blockchain. The Bitcoin system, unlike traditional banking and payment systems, is based on decentralized trust instead of a decentralized trust. Instead of a central trusted authority in Bitcoin, trust is achieved as an emergent property from the interactions of different participants in the Bitcoin system. In this chapter, we'll examine Bitcoin from a high level of tracking a single transaction through the Bitcoin system and watch as it becomes trusted and accepted by the Bitcoin mechanism. As it becomes trusted of distributed consensus and is finally recorded on the blockchain, the distributed ledger of all transactions. Subsequent chapters will delve into the technology behind transactions, the network and mining. Bitcoin overview. In the overview diagram in figure 2.1, we see that the Bitcoin system consists of users with wallets containing keys, transactions that are propagated across the network, and miners who produce through competitive computation the consensus blockchain, which is the authoritative ledger of all transactions. Each example in this chapter is based on an actual transaction made on the Bitcoin network, simulating the interactions between the users Joe, Alice, Bob and Jean. By sending funds from one wallet to another while tracking the transaction through the Bitcoin network to the blockchain, we will use the Blockchain Explorer site to visualize each step. A Blockchain Explorer is a web application that operates as a Bitcoin search engine, in that it allows you to search for addresses, transactions and blocks and see the relationships and flows between them. Popular blockchain explorers include Bitcoin Block Explorer, Block Cipher Explorer, Blockchain.info, BitPay Insight. Buying a cup of coffee. Alice, introduced in the previous chapter, is a new user who has just acquired her first Bitcoin. In getting her first Bitcoin, Alice met with her friend Joe to exchange some cash for Bitcoin. The transaction created by Joe funded Alice's wallet with 0.10 BTC. Alice will make her first retail transaction, buying a cup of coffee at Bob's Coffee Shop in Palo Alto, California. Bob's Cafe recently started accepting Bitcoin payments by adding a Bitcoin option to its point of sale system. The prices at Bob's Cafe are listed in the local currency US dollars, but at the register, customers have the option of paying in either dollars or Bitcoin. Alice places her order for a cup of coffee and Bob enters it into the register as he does for all transactions. The point of sale system automatically converts the total price from US dollars to Bitcoin at the prevailing market rate and displays the price in both currencies. Total US dollar, 50 USD, 0.015 BTC. Bob says that's $1.50 or 15 millibits. Bob's point of sale system will automatically create a special QR code containing a payment request. See figure 2.2. Unlike a QR code that simply contains a destination Bitcoin address, a payment request is a QR encoded URL that contains a destination address, a payment amount and a generic description such as Bob's Cafe. This allows a Bitcoin wallet application to pre-fill the information used to send the payment while showing a human readable description to the user. You can scan the QR code with a Bitcoin wallet application to see what Alice would see. Figure 2.2 payment request QR code. Alice uses her smartphone to scan the barcode on display. Her smartphone shows a payment of 0.0150 BTC to Bob's Cafe, and she selects send to authorize the payment. Within a few seconds, about the same amount of time as credit card authorization, Bob sees the transaction on the register, completing the transaction. Bitcoin transactions. In simple terms, a transaction tells the network that the owner of some Bitcoin value has authorized the transfer of that value to another owner. The new owner can now spend the Bitcoin by creating another transaction that authorizes transfer to another owner, and so on in a chain of ownership. Transaction inputs and outputs. Transactions are like lines in a double entry bookkeeping ledger. Each transaction contains one or more inputs, which are like debits against a Bitcoin account. On the other side of the transaction, there are one or more outputs, which are like credits added to a Bitcoin account. The inputs and outputs, debits and credits, do not necessarily add up to the same amount. Instead, outputs add up to slightly less than inputs, and the difference represents an implied transaction fee, which is a small payment collected by the miner who includes the transaction in the ledger. A Bitcoin transaction is shown as a bookkeeping ledger entry in figure 2.3. The transaction also contains proof of ownership for each amount of Bitcoin inputs whose value is being sent in the form of a digital signature from the owner, which can be independently validated by anyone. In Bitcoin terms, spending is signing a transaction that transfers value from a previous transaction over to a new owner identified by the Bitcoin address. Transaction chains. Alice's payment to Bob's Cafe uses a previous transaction output as its input. In the previous chapter, Alice received Bitcoin from her friend Joe in return for cash. That transaction created a Bitcoin value locked by Alice's key. Her new transaction to Bob's Cafe references the previous transaction as an input and creates new outputs to pay for the cup of coffee and receive change. The transactions form a chain where the inputs from the latest transaction correspond to outputs from previous transactions. Alice's key provides the signature that unlocks those previous transaction outputs, thereby providing to the Bitcoin network that she owns the funds. She attaches the payment for a coffee to Bob's address, thereby encumbering that output with the requirement that Bob produces a signature in order to spend that amount. This represents a transfer value between Alice and Bob. The chain of a transaction from Joe to Alice to Bob is illustrated in figure 2.4. Making change. Many Bitcoin transactions will include outputs that reference both an address for the new owner and an address of the current owner called the change address. This is because transaction inputs like currency notes cannot be divided. If you purchase a $5 item in a store but use a $20 bill to pay for the item, you can receive $15 in change. The same concept applies with Bitcoin transaction inputs. If you purchase an item that costs 5 Bitcoin but only had a 20 Bitcoin input to use, you would send one output of 5 Bitcoin to the store owner and one output of 15 Bitcoin back to yourself as change, less any applicable transaction fee. Importantly, the change address does not have to be the same address as of the input, and for privacy reasons is often a new address from the owner's wallet. Different wallets may use different strategies when aggregating inputs to make a payment requested by the user. They might aggregate many small inputs or use one that is equal to or larger than the desired payment. Unless the wallet can aggregate inputs in such a way to exactly match the desired payments plus the transaction fee, the wallet will need to generate some change. This is very similar to how people handle cash. If you always use the largest bill in your pocket, you will end up with a pocket full of loose change. If you only use the loose change, you'll always have only big bills. People subconsciously find a balance between these two extremes, and Bitcoin wallet developers strive to program this balance. In summary, transactions move value from transaction inputs to transaction outputs. An input is a reference to a previous transaction's output, showing where the value is coming from. A transaction output directs a specific value to a new owner's Bitcoin address and can include a change output back to the original owner. Outputs from one transaction can be used as outputs in a new transaction, thus creating a chain of ownership as a value is moved from owner to owner. See figure 2.4. Okay, so I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.